This is Mrs. Taylor. This is Unit 2, Section 2, Naming Chemicals. We want to be able to pick up a bottle of antacid and be able to name the chemicals that we see on the label. The language of chemistry is much like learning a new language like Spanish or French or German. Chemistry has element symbols, as you know, that you just took your big test today on 90 of those elements and ions. And then those symbols make up formulas, and then those formulas will make up chemical equations, just like letters make words, make sentences. So when you're naming compounds, there's some different categories of compounds, and the way you know which one you're looking at is by looking at the two elements involved. The first type is called binary ionic compounds. Bi meaning two, ionic means two ions, and compounds means to put those two together. You're going to be working with a metal and a non-metal in this case. So here's your definitions. Ionic bond is formed by attraction between positives and negatives, and these are ions that we're talking about. The positive is going to be the metal, the negative is going to be the non-metal. Binary again means compound containing two elements, one metal, one non-metal. You can see that the positive is often called a cation, and the negative non-metal is called an anion, and together they make an ionic compound. The words look like cation and anion, but you pronounce them cation and anion. So how do you know what is in the compound? When you look at the compound, you'll notice that you're going to have two elements. You'll notice that these bluish purple ones here, these are the non-metals. The yellows along the edge, where you move from non-metals to metals, are called metalloids, or sometimes semi-metals. And then the rest of them are what we call metals. Okay, when you read a compound, you'll know it's binary because it's going to have just two elements, metal and non-metal, as we said. To name these, what you do is you write the name of the metal, the cation, just as it is. Then you write the name of the non-metal, the anion, with the suffix IDE on the end. There's a little note down here at the bottom. The subscripts in the formula do not matter when naming this type. In other words, the little numbers don't have part in the name. Okay, here's an example, NaCl. You've seen this one before, so you probably already know the name without thinking about it. The Na is the cation, the Cl is the anion, the Na is your metal, it's called sodium as you know, and the Cl is your non-metal, which is chlorine as you also know, and we're going to change the ending to "ide" to make it sodium chloride. Example 2. Okay, here again we have a metal and a non-metal. The number we're not going to consider a part of the name because this metal just has one charge. It's in group 2. So when you're talking about group 1 and group 2 metals, column 1 and column 2 of the periodic table, they don't have any consideration with the numbers in the name. So this one's just calcium for your cation, bromine for your anion, and together they make calcium bromide. Okay, here's another group 1, column 1, metal off of the periodic table that has a +1 charge. Those two columns, don't worry about the little numbers in the name, you don't consider them. So this is just potassium oxide. Some more examples for you. Write the name for the following compounds. So write down your 4 compounds and name them. We've already done this one, so really there's just 3 to do here. And here are the answers. Calcium fluoride, sodium phosphide, strontium bromide. Notice here again the little numbers don't take part in the names because the metals or the cations on the front are all either in group 1, column 1, or group 2, column 2 of the periodic table. All right, let's look and see what happens when we have a polyatomic ion on the end of our compound. This is the second type of naming that we're going to look at. Polyatomic means more than one atom, because that's poly and atom, that together have a charge. And you've learned these for your quizzes. Polyatomic ionic compounds are compounds that have at least one polyatomic ion. Example might be sulfate, SO4 with a -2 charge. And here's a nice long list of lots of different ions that you come across in chemistry that are what we call polyatomic. They have more than one element in the group and a charge. Some of these you're going to recognize from your quizzes, like acetate and ammonium, and then others we did not have on our quizzes, like bromate and bromite. But if you look at the trends that we learned, you should see that they fit right in with our trends. Here's one that's a little unusual. It's called cyanide. This is a poisonous compound. It's capital C, capital N with a -1 charge. Here's another one that we did not have, oxalate, C2O4, -2. Permanganate, MnO4, -1. The rest of them I think you can pretty much figure out from our trends and from the ones that we learned together. Down here at the bottom, when you have a hydrogen combined with your polyatomic ion to make a larger polyatomic ion, notice what happens to the charge. For instance, sulfate is typically, or is, SO4 -2. But when you add hydrogen to the front of it with its +1 charge, the charge is now -1 instead. And that happens with all of these hydrogen polyatomic ions. The only cation that's polyatomic is NH4. You might remember from your quizzes that NH4 was a +1 charge. All the other polyatomic ions are going to be on the back half of the compound, the anion half, and they're all negative. The subscripts of the polyatomic ion is important, so you're going to have to pay attention to these this time. And if there are parentheses, the polyatomic ion is inside. For example, we have several here you can try. Go ahead and write them down and then see if you can name them. Here are the answers. Sodium has a polyatomic behind it called nitrate. Here's the polyatomic ion on the front called ammonium. Here's the hydroxide ion. Sometimes you can have ammonium with another polyatomic behind it, so two polyatomic ions, ammonium and phosphate, and this compound has carbonate as a polyatomic ion. Together, if you want to name this whole piece, this is sodium nitrate, ammonium chloride, calcium hydroxide, ammonium phosphate, and potassium carbonate. Okay, when you're naming a compound with the polyatomic ion, you write the name of the cation, which is either going to be a metal name or ammonium. And if the anion is polyatomic, write the polyatomic ion's name just like it is. Don't change anything about it. If the anion is a single nonmetal element, then you're going to need an IDE on the end. And we're going to look at some examples here. Here's one that we just looked at. Sodium is your cation, and nitrate is your polyatomic anion, so you just call it sodium nitrate. Okay, here's one with potassium as your cation and sulfate as your anion, so you just put the two names together to give the compound name. Here again, put the two together, calcium hydroxide. And again, ammonium sulfide. A few more to try. You can see you place the two names together, the single metal cation name with the polyatomic anion name. Calcium nitrate, sodium phosphate, ammonium hypochlorite, you remember that from your quizzes, and potassium carbonate. Now maybe you can see why I asked you to learn all those ions so that you wouldn't have to learn them while you're trying to learn to name, how to name.